In these examples, I want to go through a method called cross-multiplying. Cross-multiplying is a very useful method whenever you have an equation with a fraction in it. So, if you had this standard equation, you could multiply each side of the equation by 5 to quickly solve for x. But there is another method that we will build into with the next example that shows why it can be more useful than just multiplying each side by a value. So for example, in this example here we have x over 5 equals 13. And rather than multiplying each side by this denominator of 5, we're going to put this other side of the equation over a 1. Any number is itself over 1. And at this point we can now cross-multiply. Whenever you have two fractions equal to one another, you multiply the diagonals and the result will be equal. So x times 1, or 1x, which is just x, is going to equal 5 times 13. So 1x, or x, is equal to 5 times 13, which gives us x is equal to 65. And we could do a quick check. If we plug that back into the original problem, 65 divided by 5 gives us 13. Now, go ahead and take a moment, pause the video, and see if you can solve for x in this slightly more complicated problem. Okay, in this problem, we will now cross-multiply again. And when we do, we'll get 5 times the quantity of x minus 4. So the entire value that's being multiplied in this diagonal is x minus 4. And that entire value is being multiplied by 5. And this will equal this diagonal being multiplied, which is 3 times 2. And from here, when we distribute this 5 to start solving for x, we'll get 5x minus 20 is equal to 3 times 2, which is 6. And now we can begin solving for x. Just like normal, we'll add or subtract the constant to the other side, which we're going to add 20 to the other side to get 5x equals 26. And then to get x alone from here, we're going to divide by the number that's multiplied out front. So we'll divide each side by 5 to get x equals 26 fifths.